Okay, we're going to do one more like this. I encourage you to pause this, try and do this quotient, find our domain, and then come back and check. I'm going to give you a second to pause so that you can work on it, give it a shot, and come back and look at it. Okay, so the first thing I'm going to do is I'm going to look at my f of x in here. I want to go ahead and get this into factored form so that we can figure out where our problems in our domain are. So my numerator, we've got our x plus 6, and our denominator, we've got a difference of squares. So we're going to have our x plus 6, x minus 6. So we know that in our domain here, it's going to be all real numbers, except we cannot have our x equal to 6 or negative 6. If x equals 6, this piece is 0, and if x equals negative 6, this piece is 0. We also can look in here and see that I can actually simplify this because my x plus 6's are going to cancel out. So as long as we remember this part of our domain, that my x cannot be 6 or negative 6, then I can rewrite this as my 1 over x minus 6. That's absolutely valid. It means the same thing. For my g of x, we're going to go ahead and write this in factored form so that we can figure out what's going to go on with our denominator here. So when we write the denominator in factored form, we're going to wind up with our x plus 4 and our x minus 6. In the numerator, we can write it as the 3 minus x, absolutely valid. If it bothers you to have the x at the end, you can factor out a minus 1 and have it be the opposite of x minus 3. That would totally be valid as well. It's not going to make a huge difference either way. For our g of x, when we're finding our domain, we could realize that this is our all real numbers, except that our x's cannot be negative 4 or positive 6. So we have two excluded values there on that one as well. So then when we're looking to set up this quotient, what we're going to do is we're going to set this up, sorry, change the colors, as our one big fraction. So we have f of x over g of x. So I'm going to put my f of x, my 1 over x plus 6, I'm sorry, x minus 6, over our blue function, our g of x. 3 minus x over x plus 4, x minus 6. I'm going to fix that 6 real quick. It just looked kind of weird. There we go. So again, like in the last video, we can go ahead and do a keep, change, flip situation and try and get this to simplify a bit more. So we're going to have our 1 over x minus 6 times. So we're keeping, changing the sign, and I'm going to flip this guy upside down. So we're going to have our x plus 4, our x minus 6, and our 3 minus x in the denominator here. When we multiply these together, what we're going to wind up with is this piece and this piece are going to cancel out. We're just going to be left with x plus 4 over 3 minus x. So this is actually going to be our new function. This is our simplified form. So it's simplified down fairly small. We still need to pay attention during our domain though, because we actually have a still even now new piece to us in our domain that would give us another 0 in our denominator. So if that's not something we can spot off the top of our head with the 3 minus x, set it equal to 0 to solve and see if we can figure out what that would be. Our new excluded value that we have is that x cannot be 3. So looking at just this function, I can see that the x needs to not be 3. Working through this, we also still have here our x minus 6 in the denominator. So we know our x wouldn't be able to be 6. But in fact, we actually need to include all of these values as excluded. So my x cannot be negative 6, it cannot be negative 4, it cannot be positive 3, or positive 6. So this is going to have a lot of intervals, and we're just going to be really careful. So we're going to go from negative infinity up to negative 6. And then we've got to jump and start at negative 6 up to negative 4. Then we're going to go from negative 4 up to 3. Then we're going to jump from, oops, wrong place. Jump from 3 to positive 6, and we're almost there because our last piece is we're going to go from 6 to infinity. There will not be tons of problems where we have a domain that long. Since it's coming from a rational function and a rational function, and we wound up with a new piece in the denominator, that's why there's so many chunks out of this. So when we start combining them together, they sometimes get really messy.